Welcome to the AI innovation space. We are your experts, and I'm Iyanu.
And I'm Todd.
We're here to offer our unique insights and hold conversations with top leading innovators in the world of AI and machine learning.
We dissect and discuss the often complex realm of AI in an accessible way and go deep in discussing the innovative technologies that impact our lives every day.
This podcast is sponsored by Lumen, an IT contractor offering a creative and human-centric approach to medical imaging, cybersecurity solutions, training and support, and more. Illumin's values of ingenuity and connection make us a leader in adopting innovative technologies for federal healthcare and beyond.
Visit Illumin's website at www.illumin.com for an overview of the services offered and to read our blog series on leveraging AI for your business. Thank you so much for listening, and let's begin.
Thank you all so much for joining another edition of the AI Innovation Space. We have an amazing guest with us today. His name is Mike Sherman. Hi, Mike. How you doing?
I'm doing great. Thank you. How are you two?
Good.
Doing well, thanks.
Good. And I have my co-host, Todd. Todd, how are you doing today?
Good, thanks, Yana.
So Mike is a machine learning engineer who builds custom AI solutions for multiple customers across a handful of different industries. He has an extensive background in natural language processing, AI ethics and fairness, deep learning, and ML infrastructure. So I'm really excited about this conversation and can't wait to get us started here. So Todd, do you have anything you think we could start with Mike, just to get him warmed up here?
Well, yeah, I'd really like to hear more, Mike, about how you decided to move into and get involved with, data science, artificial intelligence areas.
I love talking about myself. It's one of my favorite topics. So that's a great place to start to warm me up. So I just want to make it clear too, like I'm here speaking as an individual based on my personal experiences. I don't speak for any of my employers, past or present, any other folks I've worked with, any customers I have. Like I have plenty of opinions to myself. These belong to me. They don't belong to anyone else. And I've had a little bit of a roundabout path to where I am. So I like to share it because I think it's important for people to see different ways to get into this field beyond getting a CS undergrad and taking some ML courses. That's obviously a super valuable, great background, but I don't think it's the only background that's necessary for an effective team building machine learning and artificial intelligence. And I say that because the sort of systems that artificial intelligence practitioners build, they exist as parts of products that serve all sorts of different use cases that need to be viewed as more than just data into a model. So I'll start from the beginning and I'll give you all the long answer. My undergrad it says it's a BS in communications, but it's actually a theater degree. They gave all the theater students communications on their diplomas, I think, to make it so that we could get jobs. And in the theater program, I focused on playwriting. So obviously really, chasing the money. But the part that's missing from that is I started in the hard sciences and I burnt out pretty quickly as an undergrad. But by the time I burnt out, I was working in a neurobiology lab, helping them write statistical analysis routines and some of the software that drove their experimental setups. I was one of these sort of stereotypical kids who had a computer, was kind of, a nerd, and tinkered, did a lot of programming on my own. And so while I would have never considered myself to, be a competent software engineer at the time, I could write code. And I was cheap and I understood the science. And so even after I switched out, the professor in the lab was like, oh, well, you can stay if you want. So I did that for 3 years, MATLAB and some C, pretty actually hairy stuff. So I was really lucky to get that experience. It definitely set the foundation for the career I'm in now. But after I graduated, with my playwriting degree, not, not so easy. I actually ended up working in healthcare for a few years. It started, sort of back office grunt, moved into medical billing work. I spent 6 months as the guy where my job was to call insurance companies and shake them down for payment. That was fascinating. It was so interesting to learn about all the parts of healthcare that maybe don't have so much to do with patient care directly. And this, of course, for better or for worse, a huge part of healthcare. And got into EHR work from there, although at that point it looked nothing like where things are at today. Didn't love, the healthcare work. Just, it's hard. Working in healthcare, it's one of the most difficult industries, I think. It really weighs on people. I was not cut out for it. I was not tough enough, frankly, to work as, part of a team providing healthcare directly. So to try to sort of start things over, I worked in video games for a while. Like that was sort of an interesting side trek, but that was also really good exposure to certain kinds of like very intense systems building that I don't think a lot of ML practitioners have, only because of the technological requirements of that kind of work. And then in an attempt to kind of sort of reboot my career, I ended up in the Peace Corps, teaching math and supporting a government educational enablement office in South Africa. From there, I went to grad school, and that's really sort of where this career begins. The program I entered was called Business Analytics. It was one of the first in the country at the University of Texas. And it was the first year of that program. And in retrospect, based on my interests, I got kind of lucky. Now it's been almost 10 years. Now I think business analytics curriculums have solidified into something that's maybe machine learning adjacent. But UT basically knew that there was an industry need for this kind of work, and they kind of threw the resources they had at it. It was sort of like, we'll figure this out. So the education I got, it didn't really look like what would now be considered a business analytics curriculum. They had us doing like Java, CS fundamentals with this poor professor who was like super skilled. It was like, why am I teaching, these like business school grunts? But I learned a ton from him. Pretty hardcore like mathematics and statistics fundamentals. And to something that I don't think like a lot of technologists or AI practitioners appreciate is like the level of like really deep quantitative work that goes on in business academia. And so, I was taking these like quantitative marketing professors, and it like turned out one of these professors, one of the largest users of the supercomputer at Texas, running these like crazy Bayesian choice models. And so it was kind of funny to discover that like, a consumer packaged goods company, like through this professor, was effectively funding like, really impactful, like low-level scientific research in the form of like, this very high-paying user of their supercomputer. And so that really set a great foundation for me. From there, I went into professional services, did some work in finance and financial compliance, did then work on NLP in the legal domain, and then my career sort of progressed from there. And then eventually went back to professional services, just because part of the reason I got into AI was the chance to like work on lots of different kinds of problems. I really do love learning about how like organizations and businesses function and how industries function, and then try to back into like where could the artificial intelligence be useful. And I think I've been now working in AI for maybe 8 or 9 years. I can't quite remember. There's a long answer.
No, that was a good answer.
Yeah, that's great to hear.
Yeah. I think we could go into like, some conversations or discussions around some of your roles and experiences. I think one thing that I really learned from just hearing you speak was the background you had that sort of built up to where it is that you are today. You talked about math, you talked about statistics, and then computer science. Those three things are really, really essential for a data scientist or ML engineer today. So I wanted to get, a bit on sort of your career background. Where did you start and things like that?
I'm going to get to this in a roundabout way, only because I want to emphasize that I think sometimes, especially when it comes to like delivering AI systems to solve a specific problem for specific users or a specific organization, I think about the Peace Corps surprisingly a lot. And I almost think about like that is like where I really started to build the skills that I need. And I'll tell a story that's like semi sort of apocryphal. I mean, some of these details may not be true. I'm not even sure I used that word correctly. And I'll tell it, and then I'll connect it back to the point I'm trying to make about artificial intelligence. So there's this brand of shoes. They're called Tom's shoes. Maybe you've heard of them. And a big part of their company, I think they're a B Corporation.
Right.
So they, doing service, doing good is very much at the heart of their company. And at least it used to be. I think they've rethought, because of what I'm about to say, like some of how they do philanthropy since. When they started, their thing was you buy a pair of these like very, hip for a while Tom shoes that were these like comfortable canvas shoes. And every time you bought a pair, they would donate a pair to someone in a developing country. What Tom's friends or coworkers or whoever didn't quite realize was some of the unintended effects of this choice. And so you could go to the developing world, to certain places where Tom's had people who would distribute the shoes, and you would see like tons of kids without shoes. Because what was happening was they kids and people that get a pair of Tom's shoes, and they were living in an area with no paved roads, eroded dirt paths, maybe on the side of a mountain, totally rocky. And these canvas shoes would just fall apart super quickly. Then making it even worse, put yourself in the perspective of a parent in a rural area in a developing country. Every few months, maybe once a year, these people come around, they give you free shoes. Your child needs a pair of shoes, but like they also need balanced, nutritious meals. They also need clothes for school. They also need textbooks. And suddenly the choice is like, well, shoes, maybe I'll just wait. And I'm very confident like this sort of side effect was not part of the plan. So I mention this a lot. And I think people who work in development, you see this a lot, is this misalignment between like what's done and what's needed. And I think that is still one of the biggest obstacles to effective AI. It's not, modeling techniques usually. It's not, the infrastructure you have like available, can you get the right hardware? And less it's even, do we have the right data? What I see a lot is like, do we know the problem we're solving? Are we aware of the unintended side effects? I see that as the most foundational thing. A lot of investment in AI is not directed properly or doesn't show gains. And it's usually, maybe sometimes, let me backpedal that a bit, but sometimes it's very much due to like the wrong problem is being solved by a huge expensive development effort. The wrong product is purchased, the wrong vendor is engaged, or superficially it looks like it's correct, but all these sort of unintended side effects start to bubble up. And it's very hard to think these things through. And actually I think that more and more is like a fundamental skill I look for in people I want to work with doing AI. Is like, do they have this like user empathy? Do they have this almost sort of like design style thinking? And can they then connect that to the technical knowledge? So I think it's a little bit of an unconventional view, but it's very much the view I've come to held. And I'm not sure I entirely answered your question, but I'll stop there for a moment.
I think that, yeah, you're going somewhere with that answer, though. I think that it's really, really critical. I agree with you 100%. I think many times people want to slap an AI ML technique on a specific problem. But, to think about the problem first, to be able to connect with the user, who could potentially use that specific problem, and to make sure you're really addressing their problem becomes really critical and becomes really, really important. And I want us to get into that conversation, but I think before we get there, I think I would like to hear a little bit about your work at SunGard, where you led patent for fast processing of stock market transaction data.
Sure. So I'm not as up in this particular subfield as I used to be. So for your listeners who are very much like plugged into financial compliance, maybe you'll get some emails. And if you do, I'd love to share them, because I don't track this problem as much as I used to. The work that was done and what the patent covers is the idea of reassembling stock market activity. SunGard invested in this because they were interested in a system that at the time, we still called this, it was a consolidated audit trail. That was an ask made by the SEC in the United States to help them better understand what happens inside of stock markets and stock exchanges. And that ask was unofficially precipitated by the flash crash, which I can't remember quite when that was, but it turned out some very interesting young man outside of Heathrow Airport, through the use of some algorithms that kind of maybe went awry, some systems he had built to trade stocks that, caused, I think it was the Dow or the S&P 500 to kind of go, but it took a very long time to figure out what happened. And so the SEC's fault was like, we need to be able to better understand what's going on in the market. And the stock market is so complex.
Yeah.
Just in the United States. I think there's 20 exchanges. Obviously, as a consumer, you don't necessarily interact with them. Hundreds, thousands of broker dealers of various scales. And of course, millions, I think, of people trading stocks. I mean, more now than ever. So from a compliance perspective, from the perspective of the SEC, who wants to really make sure that the stock market functions in a fair and proper way, because if it doesn't, it's terrible for society. It undermines capitalism. It's very dangerous. Now, the problem is, like, how do you do that? You have the
Yep.
amounts of data were massive.
Yep.
So the problem, the big insight, there were a few big insights that we had. One was that you could view stock market trades actually as a graph, as a network. And the idea behind that is, like, you're on Robinhood or at your broker, you say, I want to buy a share of GameStop because you're feeling crazy and, fun that day or whatever. And, maybe that order goes to Robinhood. Now this has become somewhat famous that Robinhood would bundle up these orders and then send them along to, I think it was Citadel, to, like, exchange them on their dark pool. But whether it's Robinhood or another app, like, that share, it doesn't just, like, go to an exchange and sit there and wait for someone else to, hit the other side of the trade. It gets bundled, it gets split up, it gets routed to all sorts of different entities who are routing back to each other, and then, you ask for 10 shares, 3 of them are filled on this exchange, 3 of them are filled directly, like, at the broker dealer, 4 of them are filled on another exchange, like, who knows? But each one of these handoffs, from, like, me to my broker of 10 orders, from my broker maybe splitting that into, or 10 shares, my broker maybe splitting that into, like, 2 groups of 5 shares and sending 5 of them to an exchange and putting 5 of them in with another group, going to another exchange. All of those were, like, points in a network, and each of those handoffs we thought of as an edge. From there, the question became, is like, well, if you have this data structure representing a set of stock transactions, how can you put it together and make it useful for a regulator? So the big breakthrough from that was the compliance requirements laid out by the SEC were basically going to require, I don't know if this is still true, but require figuring out, like, who the beneficial party of every trade was. So that meant that, like, you as a broker had to kind of know for each one of your individual transactions, like, who originated it. And to actually put this together, then, if I'm the broker and I forward it to an exchange, they'd also have to know, oh, this particular order came from this broker. And if they forwarded it to another exchange, that other exchange would have to know, like, it came from this exchange. Like, there was no way logically around including that. And from that breakthrough, then we had this, like, scale graph assembly problem. And that then suddenly we're in a space where there's some established techniques. What the patent covered was to make that faster, because assembling a graph from edges, we're talking about, like, terabytes, I think, of data every day. And maybe 7 or 8 years ago, it's still a lot now. That was really a lot back then. We actually partnered with Google Cloud, who was opening up this, they still have this service, it's called Bigtable, and it's a distributed database. It offers, really fast lookup guarantees, and we came up with really smart ways to create keys from all these edges in our transaction network. And then using some assumptions, sped the problem up, like certain characteristics of the graphs we were building, certain characteristics of the market, and had an algorithm that could then assemble. I think the SEC's ask for their compliance system was like 2 hours for a whole day's worth of stock traffic. Yeah, it's like, so yeah, that was it. And it worked. I mean, it worked in simulation. I don't know actually what happened to all that. I think some of the requirements had been relaxed, and there was a big security risk. There always is around financial data and compliance data of, you would need some system somewhere that effectively you could link a person to their individual trades. That's an obvious privacy risk to have that kind of data around. And if it were sitting in one place, a huge bounty for a hacker, be they independent or a nation state. So I actually don't know where that's all gone. SunGard ended up dropping out of the process to build the system. They withdrew their bid at some point. By then I didn't work there, so I don't know the details of that. But yeah, I think it's still sort of slowly rolling out. There's still obviously quite a bit of resistance because, it's expensive. And it's complicated. And who wants to, tell the government about their customers? It's never an easy thing for a company to agree to.
I see. Well, that was still interesting to hear about, even though I know you're a little bit removed from that particular work. So one other aspect that you mentioned briefly earlier, wanted to talk about, was you mentioned you were involved with natural language processing for a legal service product. If you
Yeah,
could
and
speak about that a bit, maybe.
I'll give a shout out to the product too, because I still think it's a fantastic product. And so this was work that I did at Bloomberg, and Bloomberg is known for the finance industry, but they provide similarly sophisticated services to the legal industry. So this particular product was to help lawyers do their legal research faster. Law is very intricate. It's very esoteric. Some say it's very boring. I don't necessarily agree with that. But so, like, when two companies sue each other, which happens all the time, most of the time, I mean, you can see this when you sort of follow the news. It's like some motion that makes no sense, and one company filed it against another, and then it takes them 3 months to rule on this motion. And it's like whether or not a specific email is considered evidence. Then they'll appeal the ruling on that motion, and these things can go on for years, especially in like mergers and acquisition lawsuits, securities transaction related lawsuits, billion-dollar lawsuits. It takes a lot of time if you're a lawyer to make your legal argument about all these different things. So what this product tried to do is to make it faster. Traditional legal search would be keyword based, like you're looking for laws around, privacy in someone's home and someone's computer. You put these things in, you hope you find a court case that's relevant. In the United States, all law, is based on legal precedent. Maybe there's a legislative decision, but often it's just a court that's weighed in to disambiguate the law. And precedent's a big deal, not to get too political, but part of why it was such a big deal for the Supreme Court to rule on abortion and change it was it's a really big deal in the legal community to remove any kind of precedent. Generally, once the court makes a decision, unless lawmakers come and override it, you want to keep that. So everything in law is generally based on like that precedent, like what happened before. And so for all these different kinds of motions and all these different kinds of contexts in like each state, like all these different jurisdictions, it's really difficult to hone in on exactly what you're finding. So what this product did, networks again, very interesting data structures, was to build a network of each piece of important legal precedent. And so what this would let you do ultimately would do these directed keyword searches where you weren't searching terabytes and terabytes of legal court text, that you were just searching a much smaller subset that was like these key ideas. The vast majority of text generated through the court system is actually really not that useful to a lawyer. So we kind of were able to get rid of all that, at least useful for like this kind of research problem. And then we also were able to kind of connect different cases together over time and create a small little network for each piece of legal precedent. So then you could find, not only like when this particular matter came up for your client, you could then see how different judges in different jurisdictions ruled on it and trace back the different cases that those judges had cited in making their decision. I don't know how clear that was to follow. It's like the exciting minutia of legal research.
Yeah, that was clear. That was pretty clear. I'm going to ask you another question, because you've spoken about two projects where you applied network analytics and things like that. So I have one question for now, and then I have another question that will probably come up later. But the question for now is, what have you used Markov chains or Markov models on your network analytics projects? Or is it just basic things like page rank of between centrality? Like, what are the ways that you mathematically characterize your network models?
This is a great question, although I'm not sure I heard of those first two techniques you said. So maybe I'm getting it over my head a little bit. Map of models or
Markov chain. Yeah.
Oh, Markov chains. Oh, this is where I think sort of my software head comes in, where I don't necessarily think of like what I was doing with these systems didn't necessarily map to sort of standard like mathematical conceptions or measurements or like generalizations about a network. I think of a network as a data structure that has some really great advantages and some like horrible disadvantages.
Right.
And the utility, I mean, this is of a data structure in general, is if you can fit your problem into a data structure, you get all this other stuff for free. For most of it for free. And so if you've got your data sitting in some kind of network, suddenly it opens up this whole world of measurement techniques you can apply. Now, not all, like you could probably do something interesting with a graph of like a stock transaction, like or a graph network, or a network representing like a legal idea. And it would be really fascinating from an analytical standpoint to like apply like centrality measurements to these different networks and see like what that would tell you. For the consolidated audit trail application, what we really wanted to do was ultimately put all this data together into a way where the regulator could then do these kinds of analyses.
Gotcha.
So almost like a step removed. It's like,
Yep.
what do you give the ML practitioner or the statistician or the mathematician that then lets them apply a whole bunch of different tools and analyses?
Got it.
So it's kind of almost a step removed
Yep.
from those. It's like setting up people to be successful. I am not an expert on network analytics. It seems like I have experience building them. And in the case of the legal application, it was using all these different kinds of NLP techniques to build those networks. And then once you have the network, yeah, I would love if like a really experienced lawyer, also knew like network analysis, could sit down with that data set. I'm sure they'd find really fascinating things.
Yeah,
It
yeah.
was kind of a step removed from that.
Yeah, no, that's exciting because the moment you started talking networks, my head starts like spinning, like, oh, okay, yeah, we got nodes, we got edges. Okay, maybe we could do this and maybe we could do that. And yeah, so exciting, exciting. Thanks for sharing. I
There's a lot of secret fans out there, I think, of like network data structures. They're super, super useful. And I know that ML community, I mean, we think about neural networks, but I don't know. In general, I think AI practitioners should think more about data
yeah,
structures and like how their information is stored and represented.
right, right, right. That's awesome. So we're going to move to the next question. Todd, do you have any question before I move to you?
Well, you can move on.
Okay. So I'm very curious how you moved into the AI ethics space. You have any experience in the AI ethics space, and what was the shift like for that?
That's a great question. This comes back to some of what I said earlier about like the unintended side effects of machine learning. And I guess just as a reflection of, I don't know, who I am or the experience I had, I had always from the beginning viewed ML as like this potentially problematic thing that would create these emergent side effects that people wouldn't necessarily appreciate. I'm not talking about like the effects on society. I'm talking about like you've trained this model on your data, you've optimized for your accuracy, you deploy it, like what may go wrong? And I think that kind of what may go wrong question is a question anybody should be asking when they are building an AI system or even training an individual machine learning model. It was just really easy to ramp up on AI fairness, AI ethics, safe AI, responsible, like artificial intelligence, algorithmic responsibility. We have a lot of terms now that are becoming vague because I just had that muscle to view every model I made as like having potential liabilities. What's been so useful about doing AI fairness, AI ethics work is that it's like a whole subfield building around this idea that all practitioners need to scrutinize their systems for unintended side effects. So that's how I came into it. It was like, well, here's a specific subset, let's say, of unintended side effects that are very impactful,
Yeah.
that have huge, damaging side effects that are very risky, that are focused on figuring out too, or discussing like what side effects may or may not actually matter. You'll lose your mind trying to ideate every possible unintended side effect of even a single model, let alone a system. And so I found that like I'll say even especially like the ethical, like the AI ethics viewpoint to be really useful for me as a practitioner because someone who really wants to do a good job, I have to always fight the tendency to boil the ocean. And so like applying an ethical lens to the unintended side effects of an ML model like starts to limit, what you need to be concerned about. The problem is then from there is like, and this is I think is one of the biggest challenges with the field of, AI safety is that you've got this like, wonderful like history grounded in the liberal arts of like ethics. And then you've got these super complicated AI systems built by mathematicians. And that's like a huge chasm. And I don't know, I like crazy problems. And also I like problems that let me like touch on the different kinds of background I had. And so that was part of the natural match too. I just felt like I was able to relate to the philosophers and ethicists, having like had this sort of odd, undergraduate education, at least for an ML practitioner, but that I could then also like grok the math and make
Yep.
sense about it and think about like shortcomings of sort of these perspectives. The traditional kind of dichotomy in AI ethics, AI fairness is, The ethicists have like a really strong viewpoint in the way they want to approach the problem, and then mathematicians have a very strong viewpoint in the way they want to approach the problem. These are still like quite disconnected.
Yeah.
And that's I think it's just so important to solve that disconnection. It's gotten so much better in the last few years that it's just something I naturally gravitated towards. And then I think once you become kind of ramped up on AI ethics and AI fairness, you can't help but notice the challenges everywhere because it affects so many systems that it's like some experience begats more experience. Yeah.
One of the
Yeah,
reasons, sorry. Yeah, I'll let you go after right now, Todd. Sorry. One of the reasons why I'm asking is it connects to the AI ML strategy question, which we're going to be deep diving into, and I'll let Todd get into.
yeah, so I was kind of going to try to tie in actually, your position with AI ethics, AI fairness into AI strategy. So before I get into that scenario, I was going to like kind of comment that, what I'm kind of gathering from what you've been telling us and sharing with us today is your unique underground background, from an AI standpoint, kind of allows you to see things a little bit differently, I feel like, than, other practitioners in the AI machine learning space. But related to the AI fairness, AI ethics question. So if you were to, come across some very well-trained model that was really well thought out by some very strong mathematicians, but it suffered from, these types of AI ethics and AI fairness problems, what would be the kind of things you would advise them to do to maybe change that model to work in this framework?
So I've done this before. I'm going to do it again. I'm going to kind of like back up a couple steps from that question and then hopefully answer it. It's much more common to be in a situation where nobody even knows what the problems might be than to be in a situation where your model has a problem and then have to ameliorate it. Now, I think in healthcare industry, the healthcare industry is further along this area than the world as a whole. So I'll caveat it with that. I expect that maybe resonates less with healthcare AI practitioners than with generalists. Where I see the most struggle across all industries right now is even beginning to like do fairness. It's really intimidating, and it's also honestly not fair to ask one individual building one model to answer a question like, is my model racist? And a lot of people boil AI fairness down to that, and that's a super important part of that. But that's not just what it's about. Where people struggle though is to even like, how do you even begin to ask or answer that question? Like, it's not, okay, I've discovered my model discriminates. I discovered my facial identification model. I mean, this is a known problem, recognizes people of certain races better than others. But to even get to that point on your arbitrary ML problem, like I think everyone now knows that they're working with like human faces. They got a whole bunch of things they need to do. If you're working on a sort of random AI problem, you really actually have to step like 3 steps back and go, okay, how will I even know if my model has these unintended side effects? What unintended side effects do we care about with our use case? And this is actually where I see the most struggle. Healthcare, like I said, has come quite a ways down this road, and it's turned into like, well, if we're building this kind of system, we kind of now are starting to know what sort of unintended side effects we might have, what needs to be measured. But getting to that first point of like what unintended side effects are possible and what needs to be measured is really difficult. What I encourage people I work with to do is to, you have to identify like, not necessarily your values as an ML practitioner, maybe that's part of it, but your organization's values as of a company. A lot of these fairness choices, they do boil down to the choice between like, it's not like good versus bad. It's like, oh, our model may have unintended side effects, but if we fix those, it might reduce the performance of it. And so like that also is not good. So we want to make sure like we don't do, bad things or unintended things. We also want to give our users the best experience possible. How do you, match these up? And that's just super tough. With that said, if you can get to the point where you've identified ways that your system may fail, may have unintended side effects that have impacts on individuals, that's usually where the fairness comes in. It's not unintended side effects where like your company loses money, it's unintended side effects that do harm to individuals. Then it becomes an evaluation problem. And I think people who, work in ML, anything outside of like an academic standpoint, understand like evaluation is one of the most important parts of the process. So when it comes to actually then doing fairness in practice, I really think then the first problem to solve once you've thought through like what could go wrong is then figure out how you're going to measure it. That may mean bringing in other data sets. It may mean slicing and dicing your data differently. It may mean custom evaluation metrics. Very often it means some manual data labeling. And then from there, you run these evaluations and then finally get to ask the question, oh, if you see disparities that are troublesome, how do I ameliorate that? So to actually answer your question, I would say this is like really specific to your model and to your problem. There's not really a one size fits all answer to this. Fairness practitioners often fall back on like some very common metrics, like equalized odds, but that's not always the right one. And sometimes these, using some of these different, well-established, like, very like reasonable metrics can give you different results. So I don't think you can actually separate the problem of how do I fix a fairness issue in my model from the system it sits in. So I know this is a non-answer, but that's really what I fundamentally believe. There's not just like a tool or a technique you can apply. You really have to like step out and think and go, okay, I have this problem. How am I going to fix this specific problem in this specific model I build in my specific like ML system, in my specific company too, because different organizations may have different value trade-offs as well. So this is why it's such a difficult area. There's not really a product you can buy here. And there's not really even yet, I think, a standard set of experience or expertise or experience that even lets you hire the right people. So, I mean, but a fun area I like to be working and interested in. That's part of, like I said, why I gravitated towards it. It's just like super impossible right now.
I see. So it's really about this specific problem, and you can't really
Yes.
generalize it. All right, thank you. And then we did want to talk about, some of your approach on ML and AI strategy. What it looks like to be effective, if you can kind of speak to your experience with AI ML strategy.
And absolutely. And I think of this sort of as two different kinds of strategy, and I'm curious which one or both, if they're worth diving into. One is at like the highest levels of a company. It's almost like CEO level strategy. Every company needs to ask themselves right now, like, how is AI going to change my industry? How's it going to change my customers and what they want? How's it going to change my competitors? What opportunities are available to my organization? I think that looks more like regular corporate strategy, but like you really need someone in the room doing that who I think has like meaningful ML or AI experience. The hype is out of control. Everyone who works in this area knows that. It's okay. The hype is a reflection of like interest and of what everyone knows is, the impact, although we don't quite know how we'll get there. But, it's like, I'll even give an example right now. It's really hard to get this wrong. Like this GPT 3.5, that chat GPT just a couple days ago, as of
Yeah, there's been a
recording.
huge rage. It's been, everybody has been all about it.
And it's amazing. I mean, it's definitely a huge step forward. I hesitate actually to call it a breakthrough, but it's close. And the quality just from a pure like grammatical and quality of writing standpoint is extremely high. That thing still spits out though so much garbage. And I don't think you have to
Yeah,
go
I
to.
saw one on like the difference between abacus computing and some, I don't know what he put out, and it was saying basically abacus computing did a better job than.
I mean, it's yeah. So on one hand, like whenever something like this happens, especially for folks who I think aren't quite as tightly connected to artificial intelligence, it's like, oh my God, and at the same time, it's like, well, let's just fire our whole call center, now we have this, and like it's like not ready, we're not at that point. So you just really need to like, I don't think any company in 2023 can make strategic decisions without, involving technologists and involving AI practitioners. So I would say like, if you've got someone who's built AI systems helping you with your high level corporate strategy, you're in better shape than a lot of people. The second part is once you determine what AI use cases matter to your company, how do you execute on those? And I think when folks think about AI or machine learning strategy, that's usually what they're thinking about. But I think you kind of got to do the first to do the second effectively. If only because if the folks who you then hire to execute your high-level AI strategy don't have some buy-in and empowerment in the view of like how that work may map to the goals of the organization, like they're never going to accomplish anything. In fact, I'd say that the foundation is often not fully laid when a company then invests in building AI because they haven't done this other work. You should really feel like it's so imperative that you have imperative use cases for your company before you even begin to start to buy or build. If you identify those use cases and you understand the impact of them, it's much more likely the second half will fall into place. But with that said, it's super, super difficult. Buy versus build is becoming a real thing. The cheap advice, which is not always true, is if it's a commodity to your business, if it's not core function, maybe you want to buy it. If it is related to the core of your business, you probably need to build it. I mean, it's pretty risky if you're a EHR company to hire out, let's say, natural language processing functionality that you want to run on medical notes. Just because, like, if your vendor goes under or decides they want to compete with you, maybe they buy a pharmacy, maybe they buy a healthcare company, like that happens. It brings risk, but also because it's your knowledge of your customers in that core area, and that will help you solve that problem really well. That will let you change, your large language model problem, let's say, a little bit to like specifically be about like maybe not even medical notes, but specific kinds of providers medical notes that will like let you deliver the best solution there. Now then from there, you've got this buy versus build decision. It's like an HR function or like something like that. Maybe you just buy it, unless you are a company that sells HR services, let's say. That's not always true, but I think that's a good place to start. If you're buying AI for your core business purpose, like you're creating like an existential risk down the line. Then what do you do? Like, this is, I think, where then really gets into the weeds and like also another place people trip up. We've decided we're going to invest in these key AI use cases that are strategically vital to us. We're hiring people. I think hiring strategy has to always be focused on production, it has to always be focused on what can we get into the product? What can we deploy like a piece of software? And then to work backwards from there. A common misstep, I think folks understand this better than they did a few years ago, is you can't just hire some like PhDs who do really cool research and some data scientists who know stats and even modeling really well. You may have challenges getting something that actually delivers business value because you need that software component. You need that engineering component. Obviously, like the easy answer is we'll just hire a bunch of ML engineers, whatever that means. Maybe a couple data scientists, maybe some researchers, bring in really open-minded business people, business knowledge folks who hopefully already have some experience in technology. I don't think it's as easy to do as people want, and it's super expensive. So what I say is there's a few things to like make this easier for you. One is like focus on the first model, then focus on 10 models, and focus on 100 models, then focus on 1,000 models. Do the 1, do the 2, do the 3. Don't just build the models, get them into production, get them in your product, even as a A/B test. Have that whole plan too laid out. It's not just we're going to build a model. It's okay, we're going to build a model. We're going to do the evaluation on it that we need. Here's the kind of evaluation we might want to get. Here's our strategy to integrate it into our product. Here's exactly where it's going to fit in our product. Here's exactly the kind of live A/B style tests we may or may not want to do in the product. These are the metrics you need to hit to know this is successful. Like just laying out that roadmap will significantly empower your folks, even if they're coming from maybe generic engineering backgrounds, maybe mathematics backgrounds that aren't quite like the perfect hires, because at least they know where they're going. At least they have something that helps them like drive the vision as opposed to I'm just going to like optimize on accuracy. And so I really encourage anyone investing in AI to take this kind of relentless approach to your use cases. And also to like, be ready to, you have to be merciless. If 3 months, 6 months, 9 months, however long pass and like that path to value is not clear on that project, you got to let it go. Most likely, if you've done the first part of strategy correctly, you're going to have way more use cases than you have people to execute on those use cases. At the risk of getting repetitive, I want to stop. But I think that sort of relentless focus on production is a key differentiator. That really is like the difference that I often see in between like teams that don't create value and do, is they start from the beginning of like, how is this going to be in our software? How are we getting to production? As opposed to like, what kind of models do we need to build? That's probably the second question, is exactly like what modeling technique we should use. Data is a big part of this as well. I don't think you can talk effectively about AI strategy without talking about data strategy. And also say that usually if you feel your organization doesn't have a data strategy, that's a better place to invest in AI. You'll see returns from that faster. It's more predictable. There's more products you can buy. It's a much more mature field. If you don't really have your data landscape in good shape, you're probably not going to succeed with AI, because AI at the end of the day is mostly about the data you feed it. That's really, it doesn't, like, the algorithms and model architectures and all that's like obviously important, but data. You can get a long way with good data and like poor ML work, much further than you can get with like not great data and like world-class ML work. And so that's the other piece, like straighten out your data strategy first. And I'll talk about data strategy for a minute or two. Without sort of getting too far out of my lane, obviously you do engineering work in AI, you have to also wear a data engineer hat. Systems and organizations I've worked with that I feel are most enabled for effective AI have a semi laissez-faire attitude towards data, in the sense where the goal of the data infrastructure, like, yes, you want things to be clean and consistent and accessible, but that you empower your data and ultimately AI practitioners to publish. You can't have this idea of like, we have our DBAs and they sit in like, database administrator land and they decide all the tables that exist and they have a bunch of stuff in normalized forms. Like, that's part of it, but you really have to empower individuals to go, okay, I'm going to create a data transformation job. I'm going to take this sort of raw data or this source data, and I'm going to create a cut of data. And I'd say one clever trick data engineers don't want you to know, I don't know, is to really enforce this idea that if you have a data set that's feeding anything in production, even if it's just like a daily or monthly or even quarterly model retraining, you as a team building an AI system or even building that data analysis or that dashboard you want to view every day, you have to publicize and promote and treat that data source like it's one of these canonical tables. It has to have guarantee, you have to document how it's updated. You have to like apply your security policies to it. You have to treat it basically as if it's just as vital as like another moving part of your software. And so by enforcing, like, look, you can't just like run some Python scripts and like dump some flat files in a file system. You want data to be accessed by your model every day. It has to be, put in our data warehouse. It has to be, treated as something that can rely on. There may be an SLA or an SLO you as a team have to commit to as well. I've seen that pattern be successful. It's that idea of like practitioners needing to publish and being empowered to publish lots of the data.
That is super cool. Wow, that was so enlightening.
It's a lot to say.
Very enlightening.
Really had fun, with that. Yeah. So should we go into some of the challenges, that people could typically face in machine learning products and models, and probably touch on some principles that you think from a compliance standpoint we need to pay attention to while releasing an AI product, because I hear you talk about production. So let's go.
I think I've talked a lot about problems, excuse me, but there's so many problems. That doesn't mean you shouldn't do it or you shouldn't try. But I think I've hit on like the problems often that I think of the most. It's like going too fast. It's like, oh, let's buy a whole ML ops system before we have like a single model even in production. You're not going to buy the right ML ops tools or whatever for your organization if you haven't kind of like at least walked through the process once or twice. You can't be too rigid. Part of that is just, this is I think a general principle with like how one manages engineering teams and creative teams. I think we're past the era that you can enforce like single patterns of usage across your whole company and be effective. And a lot of that's driven by AI and the fact that AI is changing too quickly. You can't really, like, if you can spend right now 2 years and a ton of money and time building like centralized systems to do all of your AI, you finish that 1 year project, your systems will probably be out of date. I think I heard the term ML ops for the first time maybe like 2.5 or 3 years ago. and like I think we've probably been through like 2 or 3 iterations already of like best practices that people started to agree on and then gone, oh wait. um so you can't, I don't think you can deliver on AI from that top down standpoint beyond like you got to be smart about the guardrails you choose. And you have to, you're hiring people to do AI, you're paying them a lot. If you can't trust them to like sign off that they're compliant with the security policy, like you have bigger problems than maybe your security policy violation. Like these are, some of your highest paid technical hands-on people in your whole company. Like you can't trust them to follow the rules and self-certify. You got bigger problems. And so you got to accept that uncertainty as a leader, as what you have to deal with, that you're not going to be able to build some system that these people then have to like, some rails for them to hop on. There's a good chance those rails will be out of date. I think the time to do that is like tens to hundreds of models, where it's like, okay, now we got 10 teams, each running 8 things in production. They're duplicating each other's work. They know they're duplicating each other's work. Like your practitioners will like make it they'll make it known when they're like, we're wasting our time here, or like we need to invest in infrastructure. Like let them drive it. I think it's really unsafe to buy it before you actually have, or I should say, like make a huge investment. Buy it if it lets you get your work done faster, but buy it because it's letting you get a couple of use cases out the door. Don't buy it with the idea of like, oh, we're going to get 1,000 models on this in 5 years and it's going to work perfectly. You're not going to make that decision correctly until your engineers are screaming at you to like make that decision. Your engineers, your data scientists, your AI centric product folks. With compliance and fairness specifically, I want to caveat anything I say that this is just such a difficult area. If there's one piece of advice I would give, it's one thing to comply with government rules, with regulatory advice. I can't really, that's not my area of expertise. It might be in a few years because there's a lot of AI related regulations in the pipeline right now. And I think everyone needs to be aware of this. The EU has drafts out there. I want to say that Singapore has maybe invested in this. There are some other countries as well. ISO is writing some standards. So like your compliance department's going to have some work to do over the next pretty soon, starting within a year or two. That aside, though, I think even once these regulations are more mature, there's going to be a lot of arbitrary decisions to be made. And what I always say to organizations is when it comes to these sort of fairness related decisions, every company has some kinds of values. Certainly like large organizations operating in like a sort of Western style capitalism. Like I know it's a little bit of a cliche, like our values are company, like we want to empower our communities, and people don't take these very seriously sometimes, but they can actually be really good foundations for like how your organization puts AI fairness like into reality. You don't want to borrow another company's values, just like you wouldn't borrow another company's like values, for your whole corporation or your mission statement. You don't want to borrow another organization's AI fairness values. You want to look at what matters to you as a company, look at the, trade-offs that you make as a company, your priorities, and then, craft your own idea. A very simple way to begin this is to take an AI system and go, well, what unintended side effects of this AI system may be in conflict with our organization's value statement? And that can be a surprisingly effective place to start, only because it just helps pare the problem down. It turns out that value statement is not useful. Well, that's a really great thing to know. Like there's bigger problems in your AI fairness if your company-wide values are not useful. This gets into HR and like other management things, but like you always want to empower your employees with things where they can make decisions on their own. And people tend to view like, what are the values of our corporation? What's the mission of our, business unit, is like, but if they can't use like that's a tool for you as a leader to like help people make decisions on their own. And so it's always worth investing in those and making it clear. I know it's a little bit cheesy, and in technology, in the technology industry, sometimes we can be a little like kind of maybe too into these, but that's how I always think of them. And I've worked with companies that have like value statements that people walk around repeating all the time, like in meetings. But I've also worked with companies where like nobody even knows what it is, and like you kind of got to be in the first column, or try to push your folks there before you can actually, I think, begin to build processes around AI fairness.
Awesome. Todd, go
Excellent.
ahead.
Thanks for sharing. So another question I had for you, Michael, is we've talked a bit about some experience you've had in a few different areas of machine learning. I'm kind of curious, are there applications that you think machine learning can be helpful for that we haven't particularly talked about today that you think are kind of underutilized or you think are very good, well suited for?
Oh my goodness. I don't know where to begin with that. I do. We've reached a point with AI, like a level of maturity, where I think the world in general, especially entrepreneurs, and even established organizations have gotten better at identifying like really impactful use cases. Um, where I see the underinvestment in, like as a society, is in a better understanding of like how to manage the trade-offs. People tend to react in a pretty polarizing ways to AI. It's like whether it's like it's bad, or this is good, this is great. And like these aren't going away. And I kind of wish more stakeholders sort of ask themselves, like, well, if AI is going to come to my industry, like what are the use cases that makes the most sense? And like how can I shape how that looks? I think a lot about AI as like a tool for people, as opposed to like something that automates people. And I think that's a little unusual. It certainly makes the business prospects of it less, because people do want to, cut whole units of their companies and replace them with AI. I think a lot about though ways like government, I don't think is using it as much as it could. I would love if there was like really interesting like legislative search tools. I would love if there was better, indexing of like community meetings and like, work done by like community advocates that you could search and find. Um, you hear about some applications like AI in government is an area that like fairness has to be like hyper aware. And it's really easy to go astray. And I think governments that have experimented with AI have been burnt in sort of unusual ways. It's made them tentative. One example is, I can't remember the city, but it was a phone app you could download, you put it on the dashboard of your car, and you drive around, and the phone would find like, use the accelerometer, apply AI to that live accelerometer feed and find potholes. And it sounds really great, but it was like all these like wealthy smartphone owners, in the neighborhoods they lived in, identifying all the potholes. And, experiences like that make governments tentative. But I really do think it's there. I don't think people do enough AI with geographical data. The military certainly does, but I think about like urban planning. Um, I'm sure there's some really interesting work out there, but I think it's still very early. Um, yeah, I mean, there's no use cases that are popping to the top of my head. I'm sure, 3 hours from now, I'll think of 20 and wish I'd remembered them. But yeah, I definitely think of like sectors and industries and kind of types of people. I really wish more like product designers really go to, okay, like how can I make AI make my product awesome? And it's interesting to me how people either tend to be like, I have my product, or I'm making an AI driven product, instead of going like, I know my users, I've been doing this for 10, 20 years. Like if I were a user, like where could AI like, make the edges a little smoother, or like let me do something in a slightly different way, or help me do something a little bit faster or easier. I just don't see that kind of thinking applied as much as I would like. And so it's less for me, definitely about like less about big ticket, like individual use cases, and more about really internalizing the attitude like this is going to be everywhere. And I need to understand it, because that's how I'll apply it in like less superficially intuitive ways that can like drive more incremental improvement for my use cases, for my customers, for my other stakeholders.
I see. Great. Thank you. One other question I have for you is, I think you wanted to talk about interpretable ML and
Yeah, I
how
really want
it's
to talk
not.
about explainability. I
Yeah,
really, really
yeah.
do.
Yeah, could you
Um,
could you dive into that?
I'm dying to talk about this. And this comes back to the fairness stuff. Personally, I'll say this very openly, as a practitioner, I'm really burnt out by explainability, interpretability, whatever they mean. And when I say that, it's because I think we're at a point right now where people view, okay, I'm just going to apply some interpretability technique to my model, and I'll have solved like a fairness problem. a huge part of like doing AI properly, of fair AI, is like understanding what's happening. But a lot of these sort of interpretability tools, I think they're really good for data scientists and for folks building models. A lot of them are really cool and like let you better understand what's going inside of a neural network, which is, don't get me wrong, a super important problem to solve. People who build neural networks don't really always understand exactly how they're working. And I really think that's an important thing to dig into. The problem is that's being conflated with like, what does the user of the model need to use it effectively? I see in research, there's this division between interpretability and explainability. But I'm not going to explain what the division is, because those become like smashed together in the mind of almost all stakeholders in artificial intelligence right now. It worries me as a practitioner that people confuse these. What helps you understand your layers of your neural network better is not necessarily what you need for your use case. And so when it comes to like real sort of, and I'll say it as explainability, I don't want to interpret through a translator what my model is doing. I want it to explain to me what it's doing. I really like, that's the distinction I think is important. But then even still, people view this as, let's build another system on top of the system. Something I almost never see people do. I'm like so excited to say this that I'm tripping over my words, is to go, well, we know our stakeholders need really strong explainability. We know our stakeholders, this model would say we're building a model that's for doctors to let them understand whether or not they should like administer a medication to a patient. It's like, oh my gosh, the fairness issues, like what a tough use case. So let's take our model and keep building like crazy complicated things on top of it, instead of going, how can we reframe this problem entirely to like tackle the explanation along with the modeling problem? One of the most interesting groups in research right now is Cynthia Rudin, I think at Duke, who has been doing this for a long time. And her approach often, I don't think her work, I mean, people, in academia know her. I think fairness practitioners know her, and her lab's work is a lot of the stuff that comes out of her lab. It almost feels like it lights this whole problem on fire. And so while at a headline, she's working on interpretability and explainability, the work looks totally different. And it's things like, how can we make a decision tree learner that's not greedy, that lets us learn better decision trees? So like, let's find ways to take this inherently explainable modeling technique and make it better. She's done really interesting work, or her lab has, on scorecard learning. And so when I think about things that like could be useful for a doctor, it's like, okay, well, whether or not I should administer this medication, train some deep learning model, all this explainability stuff. What if you could learn a useful scorecard that you could then test like a proper medical trial? And I just don't see a lot of people approaching their explainability problem this way, in the sense of like, is training a normal ML model even right? What other ways can I take the data and approach this problem to make something super useful and super relevant to my users? And so, yeah, whenever I hear people talking about interpretability or explainability, I'm always kind of, right now, I'm like it makes me very edgy. I almost want to say this is an overstatement, but I'll say it because I wish people would think more this way. If you find yourself in a situation asking, you're saying to yourself, I need to like build more stuff to explain what my model's doing, you need to stop yourself and ask and go, can I just build a model that's inherently explainable? So many people rush to deep learning. I think that's become something practitioners know, like that's the tool of last resort for almost any use case. And if your model's gonna have to explain what it's doing, like you want to try to stay as far away from deep learning as you can. Now, obviously it's not, you're working with images, you're working with text. I will say this too, with images specifically, I'm really excited right now by research, and Rudin and her group have done some of this, but it's become a much wider area of like, let's not just train an image classifier, let's train an image classifier in a way where it also pulls up a training example and draws boxes of like, this looks like this, And so if I have a radiologist like reading my x-ray, I would much rather they get that than a model reading my x-ray automatically, which is kind of terrifying. Or even a model that's like, well, here's the part of the model we think is like the bump. Go one step further and go, yeah, this is what we think is weird. And like, here's 5 other things where we saw that. and we think it might kind of be the same. And at least in an academic level, this kind of image learners exist. So that's like, when I think about explainability, it's like basically like change your modeling approach fundamentally. Don't necessarily think of something you can tack on that's going to help your users. Like, you got to step back and maybe rethink your whole approach.
That's super cool. Thank you so much. This was really, really enlightening for me, and I'm sure it was for Todd as well. Todd, would you agree?
Yeah, this was great, and I really appreciate you tying in the healthcare examples for our audience.
Oh
Yeah.
yeah, absolutely. I didn't know if we still, but yeah, there's so many rich AI problems too in healthcare. I think even folks who practice in other industries, you can't avoid it. You know, so many issues that are so salient to like AI practitioners in every industry, I think are salient in healthcare. You know, it's part of what makes this such a difficult field, but also like one so rich with opportunity. But all this stuff, from like scaling up your models to more data, to like new kinds of modeling techniques, to fairness and like fairness centric modeling techniques, to understanding your users. I mean, that's a huge problem in healthcare tech. Like, all these things are very salient in the healthcare industry. I do think it's a really interesting space. It's also like very regulatory, like challenging for good reasons. So there's always that conflict, I think, in healthcare between just this rich problem space and, you know, the fact it has to be, you know, regulated. I don't quite I don't quite know what else to say. There have to be rules in healthcare. You know, we're not building, you know, video games for fun. It's people's lives. Like, that's it makes it super challenging.
One
Yeah.
last question I have, I don't know if Yana, you have any further questions before we wrap up here, is just, I don't know if we quite talked about this. I know you have some experience on training people about AI ML. Is there anything you want to share on, you know, unrealistic expectations people may have, or any insights that you have on that?
Yes. So, yeah, you want me to say too? Yes, no, of course. You know, I mentioned some of this earlier. It's like, you should understand like the skills you want. But that doesn't mean, you know, you can just hire someone and have them learn everything. A lot of the challenges I see organizations have is from like only having one side of like, let's say, the set of stakeholders you need to build an effective AI system. And you can think of it almost as like, well, I know I need people who can do production software. They need to understand ML better, you know? And so like, that's the angle of training for that audience. And that may just be one software engineer on your team. And you may have a PhD or a data scientist, you know, who knows ML really well. They need to be trained more on software. Both of those need to be trained more in the industry. And then you also need a business facing stakeholder who knows the customers well, who knows the intended research use case, really well, who then needs to be trained on these technical concerns. I don't necessarily think, I don't think a lot about one size fits all kind of training for ML. And maybe I should think more about how to take someone, you know, fresh out of high school or whatever, and make them into an ML practitioner. And I know, I mean, I know people are working on that problem, and I appreciate that they are. But what I think happens sometimes is, you know, people think they can learn the parts they don't know. Like, people think they can learn the parts they don't know entirely on their own. I think the most cliched example of this, but it's true, is, and, you know, engineers who are maybe great software engineers and want to get into ML, find some tutorials, run some scikit-learn code, you know, run some TensorFlow code. Maybe they go on Kaggle, you know, they test themselves, and it's like, okay, great. That's not enough. And I think that's where like the other side of it comes in, where these other two sort of stakeholders, your ML expert, let's say, and your you know, business expert, or your designer, your product manager, your, you know, user advocate, who will come and say, well, okay, how is this relevant to our problem? I see evaluation actually specifically as an area that folks are undertrained in. If there's one thing that I would advocate for in training for ML, it's to start with evaluation. Only because if you start from other sides, things don't necessarily always fall into place. It's really easy to like learn the tech I don't know what to say. Like there's so many good code examples out there. There's so many good educators. There's so many good videos. There's so many good tools, to learn the software tools and even to learn some of the theory. I don't see a lot out there teaching people like how to frame problems. And I think the way to solve that is to like put this relentless focus to, like I said, production, but also on evaluation. And I just don't see that in training a lot. And I like to include it, like when I'm working with folks new, is like, okay, well, you know what you're supposed to build, like you have an idea of your use case, like what you want to actually like productionize or operationalize. But then the next question you should be asking yourself is like, what tests will I run to know if the model that I've built is going to meet those needs? And I can almost guarantee you that's probably not accuracy, it's probably not like cross entropy. You need to like walk a couple steps further. And I actually don't see a lot of education or training around how to do that. Like, how do you map your ML system or your ML problem? Like, how do you frame it? And I think that's a hard question to answer. That's hard training to do. But if you frame this whole problem as like, how can we teach people to evaluate their models in a holistic way? I see that as like a sort of sweet spot of where where training should focus a little more than it does.
Great. Thanks for sharing your perspectives. Yano, any further questions?
No, I'm great. This was a really amazing time. Thanks so much, Mike, for showing up and for talking.
Yeah, thank you. No, I appreciate the enthusiasm. I appreciate the great questions. Yeah, very happy to be here. It was really interesting and fun for me too.
Yeah, so
good to hear. Yeah, thanks again for coming.
Yeah, thank you all so much for joining us today. This was exciting. Looking forward to more and more of these types of conversation. And thank you so much again, Mike, for joining us. And Todd, did you have any last words? Or Mike, did you have any last words?
Just want to thank you both again. This was really enjoyable for me. I really appreciate it. And thanks to everyone who's listened.
Awesome.
Yeah, great. Thank you.
Thank you.
This has been the AI Innovation Space, sponsored by Illumin. Thanks so much for listening.
Be sure to connect with us through LinkedIn and the Illumin website to learn more about how AI and emerging technology can help you. Also, be on the lookout for our next episode coming soon. Thank you so much for joining us. Have a wonderful day.